Geometry geniuses, you're almost done chapter 1. If my planning is correctly, you just finished up a quiz, so I hope you did well on that. Keep in mind that if there were any topics there that you were unsure about or stuck on, you can always go back and rewatch the video or let me know if you need any help. I try to make everything very clear and noticeable, so if there's anything I can do to help, always let me know. Quick warm-up before we start this section, dealing with the midpoint and distance in the coordinate plane. Suppose Adam, let's say Adam's a student, scored 86% on his first exam, pretty good, then a 92% on his second exam. What is the average of the two scores? That's elementary school math, finding the average. So I know that you would take the 86, you would add on the 92, and then divide by how much? You get the 86, you add on 92, then what do you divide by? 2. Yeah, you would divide by 2. That would then give you an average of 89%, which is pretty good. You might be wondering why we're looking at an average problem, but this will eventually boil into the formulas we use in this section. So we'll continue with the next warm-up. I would pause this and try it out on your own, just so that I'm not just feeding you everything that you need. So on a number line, point A has a coordinate of -23. Point B has a coordinate of 89. Of course, not drawn to scale. What's the midpoint? What's the coordinate of their midpoint? So you know that there's all of this space between A and B. Well, how much space is that? Well, recall that we can get distance on a number line if we take the absolute value of -23 and deduct the 89. This gives us how much? 112. So that would be the distance between here and here is 112, but how exactly do we get the midpoint? We would take half of it, which would get us 56. So let's say that we jumped 56. And if we jumped 56 more, it would get us to 89. Again, this isn't drawn to scale. So what would this midpoint be? That would be 33. Look at me, 33. The third problem has Pythagorean Theorem just yelling out to you. So if you recall Pythagorean Theorem, maybe pause this, try this on your own, see if you can get it. You would eventually be squaring 3, adding on 4 being squared. This should be equal to your hypotenuse being squared. This ends up as 25 equals x squared. So x in this case will be equal to 5. And so you might be asking yourself, why did we take an average? Why are we taking distance and cutting it in half? And why are we using Pythagorean theorem to measure a distance that we don't know? Well, if we look at the formulas that we need, the midpoint formulas, whether on the number line or on the coordinate plane, use this definitely, just like we did, where if we're taking the midpoint on a number line, we would take the coordinates, add them up, and then take half. Of course, the coordinates we'll be using are going to be positive for the most part, so it's a little tricky because the example we had was negative, but we add up our coordinates, we take half of it, or we take the average. That's another way to think of it. We can also do the same idea if we are working for the midpoint on a coordinate plane, where we take the averages of the x coordinate and the y coordinates, and that gets us smack dab in the middle. And so we'll see 2 examples that show what's going on here. So if JK has endpoints of -12 and 4 on a number line, what's the coordinate of the midpoint? So recall that we can take the coordinates, add them up, and then go over 2. We can take -12, add 4, take that over 2, This gets us -4. So -4 would be our midpoint. We can do the same thing for coordinates now in the xy plane. I think it's always helpful to draw these out if you get stuck. So I know that -2, 1, 2, 3, 4, 5, not quite drawn to scale. And then 1, 2, 3, 1, 2. So I'm taking, recall, x1 and x2 over 2 with y1 and y2 over 2. Well, I know that if I add our x coordinates, -2 and 3, that gives us 1/2. I know that if I take 5 and 2, that gets us 7. And this is all over half. So our midpoint in this case would be 1/2, 7/2, which makes sense because if we were going to map this out, we would be going over 5 units, but then up 3 units. So it makes sense that in reality we go down 2.5 units, or wait, sorry, we go down 1.5 units, and then we go to the middle area, which would be 1/2, which is over here. So that'd be approximately the midpoint. In the next section, we'll see the midpoint formula if we're trying to work backwards and find the endpoints. Thanks for watching.